We are from Lab1 Sem 1 Section 1 2526. Presentation is a wrap.
We are from Lab1 Section 2 Semester 1 2526. It's a wrap.
Assalamualaikum warahmatullahi wabarakatuh and hi. So we're from Group 1 and today we're going to present about liquid extraction. So my name is Amerul Zorief bin Muhammad Rusli.
My name is Amer Razique.
My name is Idlal Isami Bakri.
My name is Hafizullah bin Hairil Anuar.
Okay, so first thing first, what I will do is I will give a shortly brief about what exactly is liquid extraction. So liquid extraction is a process to separate organic compound from its mixture, which the process involves of transferring a solute from one liquid phase to another immiscible liquid phase, which means that the liquid that involved inside the experiment does not dissolve each other. For example, like oil and water. So this process is based on the difference in solubility of a compound when it is put inside the immiscible liquid. Okay. So apart from that, liquid extraction process is widely used inside the industries such as chemicals, petrochemicals, and pharmaceuticals, which it is very suitable to separate heat-sensitive compound where distillation process is mildly quite not suitable. So, beside all the process that involve in liquid extraction, we will face or experience several problems, such as we will obtain a low concentration of the desired product. So, this problem happens when the target amount inside the mixture present in a small amount, and we will face a difficulty to extract it efficiently because most of the liquid inside the most liquid that we use is solvent and unwanted material, or we can say as impurities. So how do we solve this problem is by doing a multiple extraction or several extraction in order to get a good yield or high concentration of the desired product or less impurities. So that's all from me. I will pass to the next presenter that will show you how to conduct the experiment.
So Bismillahirrahmanirrahim. So I will show all the steps for the liquid extraction experiment by extracting the acid firstly the acid, and then the base, and lastly the neutral part. So the very first step is by we're going to weigh 0.2 gram of each solid compounds, which is basically the acid solid, and then the base solid, and then finally the neutral solid. And then after, we're going to use this spatula to take and weigh it until we get the 0.2 gram of each. So we doesn't basically need to be exact 0.2 gram. We can it can also be 0.211 or 0.199. It doesn't matter. So now we will dilute all the solid compounds with 10 milliliters of DCM, which dichloromethane. So we will use this mixture flask. I have labeled here M is for mixture. So we will dissolve all three of them in this flask, and after we add the DCM, 10 milliliters of DCM, we should shake it just lightly and swirl it until all the solid compounds are dissolved. So after we check that all the solid compounds are fully dissolved and no undissolved part, so we will use this the next step of it by using the separatory funnel. So first of all, we need to ensure the stopcock here is placed horizontally, which indicates that this stopcock is closed. So we're going to open the cap and we're going to pour in the mixture of all three into the separatory funnel. So now inside the separatory funnel is the mixture of all three. So next we will add, first we will do the extraction of acid, and then so we're gonna use 10 milliliters of 5% sodium hydroxide, and we will pour it into the separatory funnel. So now we will close it, and we will take out the separatory funnel from the retort stand, and we'll turn it upright and shake it vigorously until we are fully satisfied with our shake. So now we will place it back into the retort stand. So after we shake, and we will wait for a while until the two visible layers fully appeared, which the top is basically the acid, and the bottom will be the mixture of and plus with some DCM. So why this thing happens? Because the DCM more denser or more dense than the acid, the aqueous acid. So it will be the bottom layer, and the upper layer is the acid that we want to extract. So now I will take, because of the bottom layer is the mixture, I will take back the mixture flask and place it under the separatory funnel and open the stopcock. And after we fully extracted the DCM, we will use the acid flask and extract it. So now we will have two flasks full with mixture and acid. So we will repeat once again. So we will pour in the mixture into the separatory funnel, and then we add another 10 milliliters of sodium hydroxide. So we will repeat the extraction, and we will finally have another this situation where we will extract the mixture, and finally we will have the fully extracted acid. So now acid is done, we put it aside. So the mixture now contains the base and the neutral. So now we will continue with the base, and we will repeat almost the same steps, but we will pour in the hydrochloric acid, because now we are doing for the base. So we will repeat the same step, extracting. We'll take it out and shake it vigorously until we have until the second time we're doing it. So now we have the mixture, we will extract it out, and we have the pure base, or aqueous base. So in the mixture now is basically the neutral part, the neutral solution. So that's it, and our extraction is fully complete. Now I will pass the floor to Brother Idlal.
Okay, hello. I will explain about safety measure and precautions before we start our experiment, and during the experiment and after the experiment. So firstly, we need to apply personal protective equipment, which is PPE. And the first one is our lab coats, which protect our skins. So whenever there's chemical spillage, it will not directly hit our skins. The next one is gloves. We will use, in this experiment, we should use nitrile glove, since dichloromethane can permeate latex glove. And then we can also use safety goggles, which will protect our eyes. And optionally, we can use face shield. And last one is closed shoes. So whenever some glassware fall down, it will not directly hit our feet. So the next one is the chemical handlings. So we are using dichloromethane, sodium hydroxide, and also hydrochloric acid. So these three chemicals are highly volatile, caustic and toxic. Dichloromethanol is also carcinogenic, which if we inhale, it might cause cancer. And all of the extraction should be done in the fume hood, since the fume is dangerous. And before we start the experiment, make sure that everything is labeled correctly, because we don't want it to be mixed. And then when we want to shake the funnel, make sure that everything is sealed, the stopcock is closed, and the stopper here need to be tight. And when we shake it, make sure that we hold it properly, or we'll go whoosh, break. Okay, and then we need to vent the funnel regularly, because we don't want any pressure build up inside it. It may cause it to break. And then after we finish the experiment, we need to clean all of the glassware with soap and dispose the chemical in the specific container, because if we drain it in the sink, it might contaminate the environment. Lastly, in case of emergency, there is eye wash and shower inside the lab. And if you accidentally inhale the fume from the dichloromethane, make sure to go somewhere with fresh air and inhale the fresh air, and tell the person in charge. And also, when the chemical accidentally spill in at you, you should wash it as quickly as possible. Okay, I think that's all from me. Hafiz?
Okay, so now I'll be explaining some of the examples how they use liquid extraction in the industry. We're all familiar with penicillin used in making antibiotics. So penicillin made through fermentation, and when they are fermented, there are many other things that we do not want, and we separate it using liquid mixture. We use butyl acetate to extract penicillin from the mixture. So that's number one. Number two, they also use liquid extraction in petrochemical industries. In petrochemical industries, in the oil refineries, the petroleum is mixed with aromatic hydrocarbons and also non-aromatic hydrocarbons. So in order to separate the aromatic hydrocarbons and the non-aromatic hydrocarbons, we use organic solvent called sulfolane, and the non-aromatic hydrocarbon will dissolve in sulfolane, and then after that we can separate between non-aromatic and also aromatic hydrocarbon. And also the third example is in food industry. I believe that some of us has heard about decaf coffee or decaf tea. So in order to make decaf coffee or decaf tea, we need to separate the caffeine from the coffee without disturbing the flavor. In other words, we want to separate the caffeine while maintaining or preserve the flavor. So in order to do that, we use liquid extraction. We soak the coffee bean in water so that it will become like a liquid mixture, and then we put DCM, we mix it with DCM, and the caffeine will be separated from the coffee using DCM. So that's all from us. Thank you. See you guys later.
Assalamualaikum warahmatullahi wabarakatuh. We are from Group 2, and my name is Muhammad Aish Shamri.
My name is Muhammad Noorriza.
My name is Muhammad Afif Samsul.
My name is Muhammad Akmal bin Radzee.
And today we are going to present about liquid extraction. Okay, so firstly, liquid extraction, as we all know, is a separation process. So what is the separation process? So basically the aim of a separation process is to separate an organic solvent with to get an aqueous solution. So how does it separate? So basically when we are doing the process, there will be an action of shaking the separation funnel. So basically when we're shaking the separation funnel, the organic solvent and the mixture will separate. So the problem statements. So what kind of problem can we occur when we're doing liquid-liquid extraction? So first that I'm going to take is emulsion formation. So what is emulsion formation? So basically emulsion is a formation of a hazy layer between an aqueous layer and the mixture. So basically between this there will be a hazy layer that is caused because we did the reaction didn't occur enough for it to separate. So the emulsion will happen. And the second one is impurities. So impurities will always happen because it didn't react enough. It's just the same as the emulsion. So how we can avoid it is by we do it again, so it will react properly. So before we start the experiment, there will be precautions that we need to be aware of. So the first one is PPE. So we need to wear goggles if splashes will happen, and second one is gloves, and the last one is lab coat. The second one that we need to be aware of is handling our chemicals. So basically in this experiment we will be handling with organic solvent that is evaporated easily and quickly. So we need to handle the chemical properly by using a fume hood per se. So and the last one is basically checking our apparatus in case if it's faulty, especially the separation funnel. Because of the stopcock, it may be leaking, so we need to check before we handle the chemical. So now I will pass the floor to Brother Azim to continue.
Okay, so I will continue the presentation about the liquid extraction, but I only will present about the acid extraction. So first of all, we have a conical flask that contain a 0.2 gram of acid and 10 ml of dichloromethane. So we need to swirl it gently to make sure it is react completely, so the reaction will be occur. After that, we need to open, before we put the mixture into the separation funnel, we must ensure that the stopcock is placed horizontal, so that the solution will not pour to the down. So we put the mixture into the separation funnel, and after that we need to add a strong base, which is 5% and 10 ml of sodium hydroxide into the mixture. After that we shake the mixture and the base vigorously to make sure the reaction happen. And we must open a stopcock to make sure the pressure is out from the separation funnel. The pressure is occur because the reaction happen between the mixture and the base inside the separation funnel. So we must doing it repeatedly to make sure that the reaction between the solution and the mixture occur completely. So we put again the separation funnel into the retort stand. And after that, inside the separation funnel will be 2 layers, which is a DCM and mixture layer and the aqueous layer. First of all, before we enter a base into the separation funnel, the acid will be in a DCM, will be react with DCM because the acid is a neutral molecule that react in organic solvent. After we add NaOH into the separation funnel, the aqueous layer will be produced and the acid in the DCM will go to the aqueous layer because it has water, and aqueous layer is a ionic solvent that react with ionic compound that produce, which is the NaOH react with the acid. After that, we put a conical flask that we label as a mixture flask. So before we open a stopcock, we need to open a stopper first to make sure the atmospheric pressure help us to make sure the solution go down faster. So we open a stopcock until the first layer is go to the mixture flask, and after that we close the stopcock and we take an acid flask to place a second layer of the mixture, so that the second layer of the mixture is a pure acid that we need to use, that is a result that from a liquid extraction experiment for acid. After that, we take a mixture flask and we put again in the separation funnel and take another 10 ml of NaOH, put again in the separation funnel and do the same thing repeatedly until we get the pure solvent. Usually the more repeat we place NaOH into the separation funnel, the more pure acid that we get in this experiment. That's all from me, and I will pass to Brother Afif.
Okay, thank you, Brother Azim. So now, what Brother Azim does just now is that basically he isolates the acid part, which is we left with, imagine this is the mixture flask. We have two compounds, which is we left with base compound and also the natural compound. So what I going to do, I'm going to isolate this compound, the base compound. So first of all, the key principle here is that we have to add aqueous acidic, which is we are going to use specifically acid hydrochloric 5%. So we add it into the separate reference flask, and then we also add the mixture just now. So what will happen is that the base compound is going to react with the aqueous acid and will produce the water soluble salt, which is in our case water soluble hydrochloride salt. So when you add into the flask and then you shake it, you will see a layer, separate layer, right? So then the bottom part will be the DCM chloromethyl layer, and the top part is the aqueous acidic part, or our base compound. So we want to put, so basically when we separate the base part, so naturally we will get the bottom part is the neutral part. So we put the bottom part in the neutral flask and also the top part in the base flask. So and then we can do it repeat again to get the most to get all the base compound. So when we add when we have a base, what we have in the base flask right now is basically a water soluble hydrochloride salt. So we want organic base. So what we do is we have to specify it by adding NaOH, and we do it in the filtering pass, and also we do extraction again, and we will get when we add NaOH, the second part, it will revert into water insoluble organic base. So how to make it soluble? We all add another back again DCM, so that will that's how we will get the organic base basically. So that's all. I'll pass to Brother Akmal.
So I will continue about the result and application. So as we know, for the acidic we will combine with base, so it will produce water soluble salt, which is why we need water, so the soluble salt will dissolve in this water, and the rest will remain as a mixture. And then as we know that acidic will react with base and basic will react with acid. Both can produce water soluble salt, and the neutral will stay in the mixture unreact. And then next, for the result, we will recover the three natural compound, which is acid, base, and neutral. So the application that we have to the liquid-liquid separation, first we must know why it is widely used in the industry. This liquid-liquid separation is widely used in the industry because it can remove impurities, it can separate reactant product, and it can isolate the natural compound. For example, the first application is petrochemical sector. In the petrochemical sector, we can isolate benzene and toluene from the same reactant. The next application is from the pharmaceutical industries. We can purify drugs and recover antibacterial. And the last application is in environmental engineering. In environmental engineering, it is crucial to use liquid-liquid separation because we can absorb heavy metals in wastewater by forming metal chelates. The chelating agents will capture the metal ion, for example, copper and lead, and will be extracted from the water. In summary, this principle is used because it can purify a product, and also it can isolate the product from various mixture. That's all from us. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. We are from Group 3 and we are going to be presenting about distillation experiment. My name is Muhammad Shamim.
My name is Muhammad Arif Danial bin Muhammad Farid.
My name is Muhammad Syafie bin Muhammad Johari.
My name is Muhammad Shamim bin Zamil.
Okay, as you all know, we are going to be discussing about distillation experiment. Okay, it is one of the separation techniques that we have learned in chemical engineering lab. Distillation, by definition, is a process to separate components in the mixture based on the differences of the boiling points. Although it is just a simple technique, it is very important in both academic research and industrial application. There are three types of distillation that we should know. The first one is simple distillation, fractional distillation, and vacuum distillation. For fractional and vacuum distillation, they are widely used in industrial scale. So we are just going to be using this simple distillation for our lab experiment practice. Now I'm gonna give you a short brief about the simple distillation. First, the mixture is heated up until one of the components vaporized. The vapor is then cooled down and condensed back into liquid form. Lastly, it will separate from the mixture before. This process relies on phase changes, liquid-vapor equilibrium, and the physical properties of each substance that involved in the experiment. Although this is just a simple distillation experiment, there are several technical difficulties that could occur during the process. The major one is achieving complete separation when boiling points of components are distinct, which means each components have their own boiling points. So we need to be aware of each substance boiling point, so the experiment can be conducted properly. So the second issue is improper condenser setup. Improper condenser setup could affect the efficiency and the accuracy of the process, as leakages of vapor to surrounding could occur due to untight setup, especially in between apparatus connection. So please make sure that the apparatus are installed properly before conducting the experiment. Okay, so now lastly for the problem statement. The problem statement of this experiment is we are going to separate dichloromethane and base to obtain pure bases. Okay, now that's all from me. I'm going to pass it to the next presenter.
Alright, thank you to Brother Shamim. For my part, I will be explaining about the apparatus that we use and the general procedure of distillations. As you can see here, we call it as simple distillations. We have heat mantle, round bottom flask, we have distillation head, thermometer, condenser, and receiving flask. For each apparatus, I will explain the function after this. So now let's take example. If you have a mixture in this that containing base and DCM, dichloromethane, and how we want to separate this. First of all, we need to add up anhydrous sodium sulfates. The purpose of adding this is basically to remove the excess water. And then, after we add anhydrous sodium sulfate, we need to add up boiling stones, or for in experiment normally we use granule. The purpose of adding this granule is basically to ensure that when we boil the mixture, it will boil smoothly. So after we adding both substance, we need to pour them into the round bottom flask. So round bottom flask basically it serves as a container for the mixtures, and normally when we fill up this round flask, we fill about 1/3 only, because we want to give enough space for the mixture to vaporize. The second one we have is this, we call it distillation head, or in industry we call it as 3-head adapter. As you can see here, it's connected to thermometer, condensers, and round bottom flask. The purpose of this distillation head is basically to direct the vapor that form from the mixtures into the condenser. The third part is the thermometer. So as you know, when we heat up the mixture, it will vaporize. So the function of thermometer is basically to measure the temperatures of the vapor, not the liquid, the vapor. For our case, if we use DCM and base, the temperature will measure the temperatures of DCM because it has lower boiling points compared to the base. So for the next part, we have a condenser. Here, a condenser I can show you. This one. As you can see here, this is the condenser. So the function of this condenser is basically to cool down the vapor from here back into the liquid form. So for the condenser, we have 4 parts. This one is the outer tube. This outer tube is the tube that the water flow. Remember when we have distillations, we want the product back into the liquid form. So we supply the water here, and this is the inner outlet. The inner outlet is basically the place where the vapor pass through in here. So what will happen in the condenser is basically when the outer tube and the inner tube, this is the water and this is the vapor. The water will react with the vapor. As it loses heat, the vapor will come back into the liquids. And this is the last part, is the receiving beaker or receiving flask or beaker. The functions of this flask is basically to get our purified products. Means after we distill it, we separate the DCMs and the mixtures. We will collect it into this flask. So that's all for my part. I will pass to the next presenter.
Okay, I would like to explain to all of you guys about what is the principle behind the distillation process. The principle that behind the distillation process is VLE, vapor liquid equilibrium, which means high vapor pressure, low boiling point, boil first. Okay, as we all know, the distillation is the process where we separate a mixture of components according to their boiling point. So, with that principle, we can control the temperature to produce or to purify a desired chemical component that we want. Okay. While distillation process is widely used in industrial scale, because it's a most efficient and scalable method of separation to purify a raw material, recover a solvent, and produce high purification of product like alcohol, fuel, and chemicals. Okay. The well-known example of distillation that used in the industry is fractional distillation, where we want to separate the crude oil that contain a most complex hydrocarbon that will separate from crude oil into diesel, fuel, bitumen, LPG, based on their boiling point. First, how this process is occur. Okay, the crude oil will be heated until it vaporizes and go to the distillation column. Distillation column, fractionation column is like a block of building that have many floors, but in this we have we call a plate that will condense the vapor of the vapor crude oil. The top one has the cooler temperature than the bottom one, which is 25 and less than 25, and the bottom one has more than 365 temperature. After that, after the vaporize and contact the cooler region, it will condense and become liquid. So we will collect the product in here. Another example of industrial use of distillation process is for producing alcohol for beverage. As we all know, alcohol is the product from the fermentation of sugar that we collect from sugarcane. Okay. In that process, the fermentation product will mix with water. So how we want to separate it? We use distillation process. As we all know, alcohol is more volatile than water. So it needs a 70% degree Celsius to evaporate and then be condensed, and we get a pure alcohol exactly like 95%. Okay, that's all from me. I will pass the floor to Brother Syahmi.
Okay, for the next part, I will further extend the explanation about the precautional and safety tips for the distillation process before, during and after the process. As for the safety tips, as a disclaimer, safety tips are very important, especially to ensure that there are no emergencies or there are no accidents before, during and after the process of distillation. So as for the safety tips, for the first tip is to always ensure that you wear your lab coat and also to wear your gloves. Why? Because while handling chemicals, for example like hazardous chemicals, concentrated acid and bases, it may splash on your hands or your clothes. For example, on your hand, it will cause you to your skin to corrode, cause corrosions. So it's quite accidentally in terms of health. So for the next tip of safetiness is to ensure that the usage of this heating mantle is well explained and reminded, because while operating the distillation process, the heating mantle are used to heat up the distillation flask that contains mixture to vaporize the vapor of the pure substance. So when probably people are unconscious or unaware about the heating mantle, they without any consciousness, they touch inside the inner part of the heating mantle, which is actually hot at high temperature. When it is at high temperature, it can cause burns and also injuries on your hands or your fingers. Okay, so next, in addition, as for the precautionary steps, the first precautionary step is actually about the condensation column. The condensation column must be elevated towards pointing downwards with an angle. Why? Because if we put it horizontal, then the water flow will be hard to be flowing into the collecting flask. But if we put it like an angle like this towards downwards, then it will flow easily and we can maximize our product amount. As for the second precautionary step is to ensure that the temperature of the heating mantle or the temperature of the distillation process heating is maintained at 40 degrees Celsius. We want to obtain a pure DCM, dichloromethane. So the boiling point of DCM is actually at 40 degrees Celsius, and the base, the mixture, for example, the base is around 100 degrees Celsius. When we want to vaporize the substance, which is the DCM, we need to maintain at 40 degrees Celsius. If or not, for example, like if people forgot about the heating, it will cause it to rise, and then when we end up vaporizing the base. So we don't want it to we don't want to collect mixtures inside the collecting flask. And the third precaution step is, as we all know, we are going to insert a cold water inside of this condensation column, which is important to condensate the pure substance. Okay, so usually before we start, or not before, during the startup of the condensation process or the water input, there are bubbles inside of the inlet of the condensation column. So we need to remove the bubbles to ensure that the efficiency can be maximized and the condensation is smooth, and to collect pure substance with full utility. And for the fourth precautionary steps is to always be careful, especially in handling the cat clips. So cat clips are very important. This green thing, small thing, is very important, especially to joint the apparatus connections. If not, if we don't use the green cat clips, or the cat clips, not necessarily green, but the cat clips, probably it can slip or like this. So it can cause it to leak out of the process. And it's very dangerous in this part where the vaporization happens. So the vapor will leak out and probably contaminate all the environment surrounding the distillation process and decrease the efficiency of the process, plus decreasing the amount of product that can be collected. And that's all from us. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh, and good afternoon to Dr. Wan and my fellow friends. So my name is Nabila
I am Akma Syahira.
My name is Iffah Madiehah.
And my name is Najwa Asila.
We are from group 4 and we are going to present about the distillation. So today I am so excited because we are going to talk about a very interesting process. So basically I want to begin our presentation with a simple scenario. I want all of you to imagine that you and your friends are going for a little trip for a camping by the seashore, and then you want to make a drink, but the only available water is from the sea. So would you like to drink it? No, right? No. Because drinking seawater is very dangerous for us due to its high content of salt. So how do we make this seawater into a drinkable one? So that is the answer, which is distillation. So what is distillation? Distillation is basically you want to separate and purify miscible liquids, which is the liquids that is dissolved with one and another. So why do we need this distillation? So the answer is because nowadays we are having an increased challenges about the impure and mixed liquids. For example, the crude oil, the contaminated water, and also the waste from the industry. So these liquids, we cannot use them directly. We need to purify and separate them. So basically, the conventional methods of separation, like the filtration, is not really efficient to be used because these types of separation is more useful to separate the liquids or mixture having a different phase. For example, the liquid and solid, or to separate the mixture having a different properties. For example, one is water soluble and the other is water insoluble. So that is why we use this distillation method. And for your information, distillation already exists ages ago, even during the ancient time of Mesopotamia. So you may think how does this distillation work? So it is very simple principle that is based on the differences in boiling point. So as we know, every substance, they have a unique boiling point. So in the mixture, that substance will vaporize with its same specific melting point. The same specific boiling point. So if I have in this flask, I have the ethanol and water. So your ethanol will vaporize first, and then the vapor will be cooled down and condensed back into its liquid form, and we can collect them in a separate receiving flask. So that is basically how does distillation works. So we have a lot of distillation types, but the most common one I will state here. The first is the fractional distillation, where you want to separate liquids having smaller differences in boiling point. Second, we have a steam distillation. So this type of distillation is for the liquids that is heat sensitive. So these two will be explained later by my friend, Sister Asil. So moving on, we have the solar distillation. Solar distillation, the name itself solar, so it's obvious, it's related to the sunlight. So sunlight will vaporize and purify water. Lastly, the most familiar to us, that is the simple distillation. The right here in front of you is the simple distillation. And this one is used to separate and purify liquids having a larger boiling points differences, unlike the one I have mentioned, the fractional distillation. So without wasting our time, we are going to learn more about the simple distillation. So with that, I pass the floor to my friend, Sister Akma.
Bismillahirrahmanirrahim. For the next agenda, I will elaborate more about the apparatus and the procedure that we use to conduct this experiment. So first of all, we will use the heating mantle. The heating mantle, the function of heating mantle is to raise the temperature of the mixture that we want to use. So have you guys remember what did the mixture that we used to separate by using this method? No. So the mixture that we use to separate by using distillating method is DCM, dichloromethyl, and also base solution. So next we will have distillating flask, or this is round bottom flask. We name it as distillating flask. So we will put the mixture into the distillating flask. After that, we will put the boiling stone. The boiling stone function is to make sure that the mixture are not superheated. And then next, we will have the thermometer. The function of thermometer is to let us know what are the temperature of the mixture during we do the experiment. So after that, we have the distillating column. The distillating column is to make sure that all the vapor come to the condenser. And the crucial part is condenser. This condenser has two hollow, which is the upper and the lower hollow. So the bottom hollow is the part where the tap water flow, and the upper hollow is the part where the tap water out. So the function of the tap water is to make sure that the condenser have an inner and outlet face also. So the inner surface is a surface where the tap water flow. So the tap water will flow at the inner part. So what is the function of the tap water? So the function of tap water actually is to make sure that the wall of the outlet hollow cool. So the surface cool, because when we raise up the temperature of the mixture, the vapor will form. So after the vapor form, the vapor will flow in the inlet surface. So when the vapor flow in the inlet surface, it will contact with the wall of the outlet surface. So when the hot surface contact with cool surface, it will make sure the vapor will transform into the liquid phase. So that's why in the receiving flask, we will get the product, which is the pure DCM. Why DCM is the product? Because this between DCM and basic solution, DCM has a lower boiling point than basic solution. DCM has lower boiling point, which is 40 degrees Celsius. So that's why the DCM will vaporize first, and we will get the product of pure DCM. That's all from me. I will call Sister Iffah to tell more about precaution steps, safety, and recap about the procedure of this process.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, so today I'm going to present about the health, safety, and the precaution during the experiment. Okay, so the first part I'm going to present is about the health and safety. Okay. In this experiment, we will handle a lot of chemical substances that are really corrosive and can penetrate our skin. So we need to wear our lab coat and also gloves. Okay. The next is in this distillation, we use the heating mantle instead of the Bunsen burner. Okay, why? Because Bunsen burner is an open flame that it will easily ignite the solvent vapors. So we use the heating mantle, as it will provide the indirect flammable heat, and it be more safer for the flammable solvent. Okay. Okay, next I'm gonna present about the precaution during the experiment, but I will also explain about the recap of the procedure that Akma said before. Okay, so first thing first. Okay. Before we do the distillation, we have the liquid extraction. So we need to insert a bit of anhydrous sodium sulfate to remove the excess of water. Okay, so this is the first precaution. And then the remaining liquid we will put into the round bottom flask. And then the round bottom flask, we will insert a bit of the boiling stone. The function of boiling stone is to evenly heat it evenly in this round bottom flask. So this is the next precaution. So then we will put into the heating mantle. But before we turn on the heating mantle, we need to make sure that our water flow. But we will flow the water from the bottom to the top, so that the water will coat entire condenser, So it will increase the cooling efficiency. So the paper will turn into liquid more efficiently. And then this is the next precaution. When we turn on the heating mantle, we need to monitor the temperature and stop at the boiling point so that no other compound will vaporize in this distillation. So when we turn on the heating mantle and it reach the boiling point, we will stop the heating mantle, and then the vapor will start to evaporize and meeting the cooling water, and then the liquid will form at the end, and we will get the pure dichloromethane. And as we remember, the pure dichloromethane are really corrosive, and that it's really corrosive toward plastic, so do not play it like water. Okay, so that's all. I will pass to Najwa Sila.
Alright, so next I will explain on the industrial application of distillation principle. So in industry, it involved with a more complex distillation process with the use of larger equipment to produce larger outcome of distillation product. So the most prominent industrial application is the petroleum refining, which is the fractional distillation of crude oil. So crude oil is a complex mixture of hydrocarbon with varying boiling points and density, and it is a natural liquid fossil fuel found underground. So this oil will fed into the distillation column or distillation tower or fractionating column, and will be separated into many layers. And each layers holds a different petroleum product, such as petrol, diesel, kerosene, naphtha, and many others. So in this fractionating column, at the top of the column, it has smaller or less dense molecules which are more volatile, ignite easily, and have a lower boiling point that will vaporize first when the crude oil is heated. And at the lower section of the column, it has a bigger molecule and more dense heavy fuel, which are harder to ignite, less volatile, and have a higher boiling point. So the product formed in these different stages will be collected to be used in various purposes, such as petrol for car oil and also bitumen for making roads. And then the second application is the essential oil extraction, which implemented the steam distillation process as a common method for isolating essential oil and flavored compound from plant material by heating and condensation. So this process uses the hot steam. So when the hot steam passes through the plant material, the heat energy from the steam will break the oil gland and vaporize the essential oil in plant. So this oil become vapor. It will mix up with the steam. So the vapor mixture of steam and oil will then pass through the condenser, where it is cooled down and condensed back into liquid. So this condensed liquid will have two distinct layers, which is the aqueous layer and also the oil layer. So the oil layer, being more immiscible and less dense than water, will float on top of the aqueous layer and will be separated using the Florentine flask or oil separator. So this method is widely used to obtain the natural flavor extracts such as lemon, rose, and vanilla oils, which are used in perfume and also food industry. So steam distillation is more preferable to be used in this process because it can prevent from overheating, preserving the aroma and quality of oils. And this process is also environmentally friendly and does not involve with the harmful chemical, making it ideal for food application. And the last example on the application is in the water treatment industry. So for water treatment, distillation is used to obtain the high purity of water or distilled water by separating water from dissolved impurities or contaminants based on the differences in boiling point. So this process relies on the principle that pure water have a lower boiling point compared to most salt, minerals, and non-volatile impurities. which means that these impurities do not vaporize at this temperature where the water vaporizes. So this method uses the simple distillation, which means that water will be heated and it will become the vapor. So when the water vaporizes, it will leave behind the non-volatile impurities, and when it passes through the condenser, it will condense back to liquid. So this condensed water is now free from the most impurities and have a low electrical conductivity, indicating high purity of water. In some systems, they even use the multiple effect or vacuum distillation to reduce the energy consumption used in this process and allow distillation at lower temperature, preventing the scaling or corrosion in the equipment. So to conclude, distillation plays a big role in our daily life to provide with the purified and valuable product to support our health and comfort. So that's all from us.
Assalamualaikum and good afternoon to doctor and fellow friends. We are from Group 5, Section 1. My name is Nabila binti Shahrudin.
My name is Adila binti Muhammad Hanafiah.
And my name is Aisha binti Amir Hamzah. My name is Noorriza binti Osman.
And we are going to present an experiment called thin layer chromatography. Bismillahirrahmanirrahim. To begin this experiment, is actually use the technique, and the technique used in this experiment is actually what is actually the core of our experiment today, thin layer chromatography, or known as TLC. So basically, to introduce this concept, let's take a look at a brief example, okay? When working with natural extracts or chemical reaction mixtures, we often encounter multiple compounds mixed together. So when the components or the compound, mixed together, so we have to determine the target compound that we want in order to identify the compound. So basically, at this point, you guys might be wondering or questioning how does this technique operates, right? So basically, TLC works on a very simple principle. The silica gel will interact with the polar compounds, and when it's interact with the polar compounds will move slowly when it's direct with the silica gel, and it will remain near to the baseline. While for the non-polar compound, the interaction between the non-polar compound and also with the silica gel is weaker, the interaction between them. So basically, the non-polar compound are swept further up the plate by mobile solvent. So basically, this technique is actually not only used in the laboratories academically, but also used in the pharmaceutical analysis for identifying the unknown compound efficiently. So basically, the problem statement that we used for this experiment is, by applying the thin layer chromatography principle, how does the calculated retention factor or RF value used to determine the identity of an compound that we want to know. So basically, to achieve excellent identification, we requires highly controlled and also safe experimental environment. So in order to achieve that situation, I would like to call the next presenter, Sister Amani, to talk and guide us about the safety and precaution on the experiment.
Okay, thank you to Sister Shabila. And today I will explain for the safety and precaution of TLC experiment. First of all, I would like to say that I will explain this into 3 parts. Before the experiment, during the experiment, and after the experiment. Okay, if you guys know, before we do any experiment, we have to wear a proper lab attire, such as lab coat and gloves. This is very important because we want to deal with the chemicals. So we want to prevent ourselves from any harmful chemicals. Okay, next, all the stuff that we have, we must to label it first, just like this. We have to label it. Why? Because we want to make sure that don't have any confusion or misuse or mixing random chemicals. Okay, next we move on to the next part, which is during the experiment. Okay, during the experiment, for the TLC experiment, we use acid and base. Such as we know that acid and base are very harmful. So we have to deal with all of deal with the chemicals perfectly and gently. We must to make sure that we close the container that contains acid, especially acid and base, because the acid and base will very fast evaporate. So we want to prevent from that happen. Okay, and next, in TLC experiments, we have to plotting the sample on the silica plate. So silica plate this very sensitive. So the oil or dirty from our hand might be disturb the movement of the sample. So we have to make sure our client is clean and also wearing the gloves. Okay, next. Next. After we plotting the TLC on the after we plotting the sample on the TLC plate, we have to see the TLC under the UV light. So in our lab, we do not use UV goggles, but we use a shield, a plastic shield that that block the UV rays from us. This is very important because as we know that UV rays are very harmful, so we must to make sure ourselves do not contact directly with it. Okay, and last part, which is after the experiment. After the experiment, we have to clean up all the containers and put it back into their original place. And also, in our working place, we have to make sure it is all clean, and we have to leave the lab with safe condition as we go into before. Okay, that's all from me. I will pass this to next presenter. Thank you.
Assalamualaikum. Thank you, Sister Amani, for explain about the procedure just now. So, assuming that I have followed all the procedure, just wearing lab coat and also wearing glove. So, before I start, basically, as we know that TLC is a thin layer that's coated by the silica gel. So, we take these two thin layer surface and then we label it 1 cm from the bottom and top using ruler and also pencil. And also at the bottom section, we have 3 sections basically. Acid for A, B for base, and also N for neutral. And then do it for both thin layer, okay? And then we have 3 beaker, which is acid, base, and also neutral. For these 3 beaker, we put respectively with the DCM for each. The amount you can only approximate, okay? And then we moving here to the what we call the flask, and we take 2 flasks here. For first one, as the sister Amani said, we must to label. So I label as HE, or we call as hexane and ethanol, with the ratio of 9:1, which is 9 ml of hexane and also 1 ml of ethanol. So we take these 2 solution in the fused cardboard, okay, and then we pour in the flask. Okay, for the second flask, we label it as DE, which is first one is DCM and the second one is ethanol. So same ratio, which is 9:1, 9 ml of DCM and also 1 ml of hexane. Okay, so here we have the measuring cylinder on top of the filter funnel. So we take the first flask, which is I assuming as what we call HE, which is hexane and ethanol. I pour here to 5 ml, okay, and then let's focus only for the first measuring cylinder. I pour here until you see the 5 ml, and then from there you pour into the hexane and ethanol chamber. Okay. Same goes to the second measuring cylinder. We take the second filter, second flask, which is labeled is DH, which is DCM also hexane. You pour into the measuring cylinder on top of the filter funnel, and then you transfer it from the measuring cylinder to the chamber, which is labeled also is DCM and also hexane. And then you take the So this is the capillary tube. We have 3 capillary tube, and then you take the you take these 2 thin layer. Okay, I started with the acid. Okay, just we dip the churros, so we dip into the solution of acid. So you take the acid, and then at here, as you remember, we label is the section A, B, and N, acid, base, and neutral. So for the A, you just dip onto it. You spot onto the thin layer for both thin layer in the A section. Okay. And then for the second dip, so you take for the base, and then you spot onto the B section for these 2 thin layer. And then the last capillary tube, you take from the neutral solution, and then you do same thing. You spot into the N section at this 2 thin layer. Okay, after that, you take the forceps, okay, and then you take this thin layer, the first thin layer, this also labeling as HE, which is hexane and ethanol, and then you look at the chamber of labeling hexane and ethanol, and then you put your thin layer. Okay, until where? Until when you want to break there? So until you see the solution goes up to 1 top from the 1 cm from the top. Okay, until they reach the line that we already measuring earlier. Okay, and then for the second, and then you take it out, assuming you already done. And then for the second thin layer also, you put on the chamber DCM also hexane. Same also, wait until it reach the top layer. Okay, and then you you take care out. Okay. So we have these two thin layer that already put inside the chamber, and then now we want to see the result because we can't see the result now. So we're using the UV light with the wavelength, short wavelength. Okay. So so assuming that I have the UV light, and then you put same that Sister Amani said that we shield ourselves by the plastic, right? Okay, from harming us. So as the result, we can see on both of these thin layer, the result will showing us based on the RF value, which is indicate their polarity and the movement of the solution, this solution, through the silica. So I think that is already end for my section, which is the procedure. So I will pass to my next presenter. Okay, thank you.
So before I proceed for the next part, I will show you the better illustration for the result that we can get after we show the UV light. Okay, so I will continue next part. To get a better understanding on TLC method, I will explain about real-life example on principle of TLC applied in today's industry. So, have you ever wondered that this cosmetic and this perfume is actually safe for us to use even though there is a chemical and alcohol inside it? So, this is how TLC methods comes in. It's ensure the safety and quality of the products that we use nowadays. So in cosmetic industry, we use TLC for quality control by verifying the ingredients that we use is suitable or not for the product and free from contaminants. Besides that, it is also used for stability testing to check if the ingredients degrade over time due to heat, air, or lights. Besides that, TLC plays roles in environmental testing. It is widely used to identify the pollutants and chemical contaminants in the environmental sample, such as water, air, and soil. Environmental scientists usually use TLC methods as a screening role before they proceed to the next, to the more advanced analysis because it is fast and inexpensive. So last but not least, in forensic science, we can utilize TLC by identifying unknown substance that we find in a crime scene, such as poisons, drugs, and explosive residues. It is very valuable for forensics as it came with a rapid results that can help them to the further investigation. So that's all from us. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. We are from group 6. We are going to present about TLC, which is thin layer chromatography. My name is Muhammad Wazif Wafi bin Syed Ibrahim.
My name is Siddiqah Husna binti Ahmad.
My name is Sarah Naziha binti Rashid.
And my name is Noorriza binti Muhammad Azam.
Okay, I will start with TLC. What is TLC? TLC is thin layer chromatography, a solid liquid partitioning chromatographic technique to determining the purity of material and preliminary identification process. So to put it in a simple word, this TLC is a separation technique to separate and identify a component of a non-volatile mixture. So the importance of this technique is basically to understand the structure of the silicate material on the TLC plate that have hydroxyl groups which are polarized and can form dipole-dipole interaction with other polarized substance. Okay, when the solvent mixed with the component, it will rise up as it interact with the stationary phase, which the plate starts from the mobile phase is the solvent. So it will drag along the components to the solvent front. So this component we can determine after the UV ray the UV ray extraction. So in chromatography, we can measure the distance travel using the RF value. The RF value obtained is from the distance travel by the substance over the distance travel towards the solvent front. So a problem statement can concern in these studies about each component have different type of polarity and how it interacts with the solvent phase. So we can focus on how to calculate and sure that how this polarity affects our calculation, and is this separation success and accurate to our calculation. So that's all from me. I will pass to the next presenter.
Okay, I will talk about the precaution and safety. Okay, first of all, before do some experiment, we need to wear lab coat, glove and the closed shoes. Why? Because we are dealing with some harmful chemical reaction that can irritate our hand and our eyes. Okay, why we need to wear it? Because while we do an experiment, there are any harmful chemical solvent that can spill onto our hands. So we need to prevent it. After that is while we are drawing at the TLC plate. Okay, we must use pencil instead of pen. Why? Because pencil are made from graphite. So graphite are insolvent into the solvent. So the baseline and the mixture will stay fixed. Okay, pen have chemical. At the ball pen, it have additive which are function to preserve the ink. So it will affect your sample and avoid UV detection. Okay, after that is we must not touch with our hands at the baseline and the front solvent between the space, because our hands have impurities that can affect our sample too. Okay, after that when we deal with the UV light, okay, UV light is too dangerous for us. Okay, how to deal with UV light? We deal with UV light with we view the sample through the sample of the plate transparent. So it can prevent from any dangerous, because it can cause cancer when you deal with a long time at the UV light. Okay, UV light can also cause our cornea destroyed. So it can irritate our eyes and give pain to our eyes. Okay. Lastly is after we do the experiment, we need to dispose any chemical solution and the TLC plate onto the right container. Okay, it must do it before because to prevent any contaminating and fire hazard. Okay, that's all from me. I will pass to the next presenter.
Next, I'll be demonstrating the experiment. So before we start the experiment, I'll introduce the equipment that we need first. We will need a beaker, a forceps, a measuring cylinder, a capillary tube, two developing chamber and also a filter funnel, and lastly we also need the most important part is a TLC plate. So to start the experiment, first we will do the sample. So how to do the sample? We will have three different sample, which is acid, base and neutral. So each of the sample we will mix it with 5 ml of dichloromethane, and then we will set it aside. And then next we will do the developing solvent. So for the developing solvent, we will have two developing solvent, which is first we have the mixture of dichloromethane and hexane, and second one is hexane and ethanol. We will prepare 10 milliliters, but we will put it into the developing chamber 5 milliliters only using a filter funnel and also a measuring cylinder.
Next, we will prepare the TLC plate. So for the TLC plate, we will draw a two line. First, at 1 centimeter from the bottom line, and another one is 1 centimeter from the top line, and also we have to label it A, B, and N, which is indicate acid, base, and neutral. So next, after we have done preparing sample, developing solvent, and also the TLC plate, we will spot or dot the TLC plate with the sample that we have prepared just now. So use a separate capillary tube so that the sample won't get mixed. So put the sample exactly at the label that we have labeled just now, acid, base, and neutral. So after we have done spotting, we will take the capillary tube and develop it in the developing chamber, gently and nicely. So after we have developed it, close the lid and let it rise. Let the solvent rise until the solvent front, which is the line from 1 centimeter from the top. And then after it has reached the line, we will let it out and let it dry. After it has dry, we cannot see the sample that goes up with the solvent with our naked eyes. So how do we visualize it? We will use this UV lamp, and we will use the short wavelength one, which is we will cover it with a paper plastic, so that because the wavelength is somehow dangerous, so it cannot touch our skin. So just visualize it using the UV lamp, and we will see the spot. And to mark it, use the pencil to us to see it. Okay. So that's all from me. I'll pass to the last person.
Okay, so since we have discussed about the theory part of TLC, now I am going to tell you guys about the application of TLC and where TLC is used in industrial settings. So first and foremost, TLC, perhaps the most critical application is in a pharmaceutical industry. In pharmaceutical industry, TLC is a method to do a work in a large amount for quantity control, and it is mainly for purity testing. For example, when a chemist wants to produce a batch of drug like paracetamol, a technician needs to test for its purity. So what they do is they spot a new paracetamol that they want to produce next to a paracetamol that has been standardized and see the result of it. And if they spot the layer, after the TLC is run, if they spot the layer is the new spot is the same distance with the standardized paracetamol, then it is testified for and it is purified. And if another spot is located at the TLC, that means that impurities are present and they need to bring the new batch for more investigation. Next, still in pharmaceutical industry, TLC is also used for reaction monitoring, where when a chemist want to produce a new complex drug molecule, the reaction can take up
hours and even days for it to complete, and they can't wait till the end to see if it is complete. So what they do is they still use TLC plate and still spot the reaction mixture every hour and run in TLC, and they can see the real-time progress. So next, in food industry, food and cosmetic industry, TLC is used for TLC is used. Let's move on to the next application, which is in biochemical analysis. In biochemical analysis, TLC is used for isolation and separation of biochemical constituents and constituents in blood plasma and blood fluids for clinical analysis and clinical research. So to conclude, TLC is not just for academic exercise but also important in purify medication, for protecting food safety, and also confirming clinical analysis. So since using TLC, it is simple, cost-effective, and fast in producing products. So it is mainly a method that is used in industry. I think that is all from me. Thank you.
Assalamualaikum everyone. We are from group 7. My name is Noorriza Kalisa.
My name is Nurul Husna. And my name is Nurul Alia Balkis.
Today we will be discussing about recrystallization. Recrystallization is the most easiest and the effective ways to purify an organic solid. So basically, the idea behind the recrystallization is quite simple. When the crystal is formed, then the only correct molecules will fit perfectly into the crystal structure, leaving behind the impurities behind in the solvent. Next. The most important step in this process is choosing a good solvent. If the compound is known, then we will refer to the literature. Then if the compound is unknown, then we will test several types of solvent to get the most suitable solvent for the compound. Then we will follow the rule light dissolve lights, which is polar compound will dissolve the best in the polar solvents, and the non-polar compounds will dissolve the best in the non-polar solvents. A good solvent will have several qualities. First, it will dissolve a lot of compound when it is hot, but when it is cold, it will dissolve small amounts of compounds. Second, for the impurities will be insoluble when it is hot, but when it is cold, the impurities will be slightly soluble. Then, a good solvent also must have a boiling point of between 50 degrees Celsius to 120 degrees Celsius, so it can easily evaporate. Lastly, the solvent must not react chemically with the compound that being purified. Now, the problem for this experiment is almost all the organic solids will have impurities. So, to fix it, we will use recrystallizations to remove the impurities, and we'll get the pure crystals. before we start the experiments, the safety must come first. For the PPE, we must wear the goggles, lab coats, gloves, and closed shoes. And next, in this experiment, we use hexane and methanol. For the hexane and methanol, it is very flammable, and the methanol is also toxic. So handle them in the fume hood and keep them away from the flames. To heat them both, use a hot plate or the steam bath instead of Bunsen burner. Next, during the vacuum filtration, set up the apparatus properly and securely, and don't touch the crystal with bare hands, and wash your hand after handle the chemicals. And report to the lecturer or the lab assistants if there are any chemical spills. That's all from me. I will pass to the Sister Husna for the procedure.
So for the next part, I'm going to explain about the equipment that we're going to use and the procedure. So first, we're going to use 2 conical flasks, which is we're going to label as a single solvent flask and the mixture solvent flask. And then we need a hot plate, which is we're going to use for the heating our solvent later. And then we're going to use pump filter and this porous filter funnel. This is crucial for the final step later, which we're going to separate our dry crystal from our solvent. And then we're going to use 2 graduated cylinder and dropper and spatula, this is for the measuring and transferring tool, which is we're going to ensuring that we use the right amount of solvent. So first, we're going to put our dry acid precipitate using spatula, add half into the single solvent mixture and the single solvent flask, and then other half into the mixed solvent flask. And then we are going to measure our hexane, 5 ml of hexane, and pour it into the single solvent flask, and then use other graduated cylinder to measure 5 ml of water or methanol and pour it into our mixed solvent flask. And then after that, we're gonna put both of our flasks on the hot plate, and then we're gonna heat it up and until it boils. Once it boils and dissolves, we're gonna cool it down. For the single solvent flask, we're gonna use only room temperature to cool it down, and for the mixed solvent flask, we're gonna immerse into the ice water bath, and then we wait for a few minutes, and we're gonna observe what happened for both of our flasks. So for the single solvent flask, we're gonna see that the crystal that produced is more clear, is more beautiful and larger because of the cooling process that we use. It gives the acid molecule time to align themselves perfectly. And for the mixture solvent flask that we immerse into the ice water bath, the dry crystal that produced is less defined because of the acid molecules crash out the solution fast. So for the vacuum, next for the vacuum paper, I'm gonna pass to the Sister Alia.
Alright, so I'm going to talk about the vacuum filter. So this is the vacuum filter with, Alright, so as we know, there is like mixture solvent and the single solvent here. Okay, so first of all, we're gonna cut this filter paper to fit this into the filter funnel. So we put here, and then we do it one by one. So first we're gonna put a single solvent into this, and we're gonna observe it. And before that we have to plug the switch and make sure it is on. And after that we take out the crystal that has formed and we put it aside and let it dry a bit. And after that we put another filter paper, we cut it also and put it here. And we put the mixture solvent that contain methanol and water, we put it here. And after that we wait for some time and we take out it, we put it aside. Alright, so as we can see, there's two different crystal form, and as Sister Husna said, the one that for mixture solvent that is cooled by the ice bath, it is formed like more not aligned and not like beautiful, because the molecule form has no time to arrange themselves, and it is a bit disordered. Unlike the single solvent which contain hexane only, since we cool it to the room temperature, the crystal form is more beautiful and the molecule like more clear. And since, as I said earlier, it is cooled to the room temperature. Okay, so we are done with this vacuum filter. Oh, and make sure to turn off the switch. Alright, so I'm going to talk about the application in recrystallization process. So we as a chemical engineer, of course we do a lot of recrystallization process, because it is a crucial process in the industry. So first, for example, in the in the pharmaceutical industry, we extract the drugs, for example, paracetamol and ibuprofen and radinidine. We want to purify them by remove and purify the contaminants and get their products, so that it will be safe to be consumed by the consumer. And then we move to the nanoparticle synthesis recrystallization. So in the nanoparticle synthesis recrystallization is involved in the process, so that they can again extract the contaminant, and we will get their final product. Okay, and next also in the food industry. Okay, of course, in the chemical industry, we have the food technology also involve recrystallization. So for example, okay, the objective is to be used in most common item and additive. Okay, and for example, benzoic salt. So benzoic salt is used in the food, to cook and to add more and act as enhancers and preservative. Okay, and the last one is in the water treatment. Okay, aside from all those chemical processes such as distillation and TLC, we also use recrystallization in the water treatment. Okay, so how is it act like? So first we're gonna extract, we will use recrystallization to extract the pure water from the desalination plants, and to extract pure water from the saline sources, and we also will extract also any valuable minerals to get the pure and clean water. Of course, not only recrystallization involved, but we also involve many processes to get the clear water. And to sum up, recrystallization also plays a vital role to get a better products, and it is very critical in ensure the product safety and product efficacy so that we can be consumed to the consumer as well as the society. So that's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And hello there. We are from Group 1 for Section 2. And we will be presenting on liquid extraction. So first and foremost, my name is Afif bin Azizan.
My name is Hazim bin Muhammad Atifi.
My name is Abdul Hazim bin Sulaiman.
So I'll be passing the floor to Brother Hazim to explain the introductions on liquid extraction.
So for introduction, my responsibility is to tell you about the introduction, problem statement, and the precautions. So, what is liquid extraction? Liquid extraction is a type of separation that separate liquid extraction is to separate chemical compounds or organic compounds that differ in solubilities into immiscible liquids. So in liquid extraction, it involves from organic compound from an aqueous solution. So how liquid extraction can be done? So liquid extraction can be done by mixing the aqueous solutions with the immiscible solvent that will separate all the organic compound from the aqueous solution. So from immiscible solvent, what kind of immiscible solvent will be used in this experiment? So the immiscible solvent we will use in this experiment is dichloromethane, which is DCM. DCM is a non-polar organic solvent that are immiscible with water, and also it is also efficiently dissolved and separates all the organic compound from an aqueous solution. So the necessity of liquid extraction is to separate and purification. So like we have a mixture contain. So for example, this is a flask that contain a mixture that contain acid, basic, or natural. So we want to separate all this kind of mixture by separate, for example, acid, basic, or neutral, and by using the solvent that is DCM. So next, I will explain about the precautions. So the precaution, like we all know, we have to use a lab coat, long sleeve lab coat, and before the experiment started, we have to wear a glove. Why we have to use glove? We use glove because during the experiment we are involved with the. For example, we involved with the acid like NaO and base like acid like HCl and base like NaO, and both of the base and acid is very severe to our skin, and it's very severe to our body if we inhale it or we ingest it. So do not do that. It is dangerous. And when we prepare the DCM, do not inhale the DCM because DCM will give you many side effects to your body. Okay, that's all from me. I will pass it to the next presenter, Imran.
Hello there. So I'll be presenting on two matters. So what I would like to present on is basically like, first, how do we get the mixture in the first place? Like, we are going to do liquid-liquid extraction, right? So of course we're going to have the liquid from which we're going to extract another liquid from. So basically how this is done is going to be explained by me further in my speech. And second, I'll be explaining on how do you extract acid from your liquid mixture. So let's start with my first point. So the first point here is that we're going to have a flask. Let's just assume this is the mixture flask, shall we? So this mixture flask is going to be the flask that's going to be containing all of our acids, base, our neutral compounds, and our organic solvent, which is going to be dichloromethane. So another thing to consider, why do we have 3 other flasks? So basically, these 3 other flasks will be used to, so when we do the extraction, we're going to have other results. Mean to say, we're going to have an acid result, an acidic solution, we're going to have a basic solution, and we're going to have a neutral solution. So basically, we're going to need these 3 flasks. So per every time we do this experiment, we're going to extract first acid, then base, and then finally what's left is going to be neutral. So how do we get our liquid mixture in the first place? So basically our liquid mixture is going to be composed of powdered acid, powdered base, and powdered neutral. So of these, basically you're going to take 0.2 grams of each and put it in this flask, the mixture flask as such, and then you're going to add 10 milliliters of DCM into the flask, and then you're going to mix it together. You just shake it up until you see that everything is sort of well mixed, or as best mixed as possible. So when you have that mixture, first you're going to have to get it inside our, what is this called? Our funnel, right? So basically, to get it inside the funnel, let's just remove this, shall we? So basically, you're going to remove the cap. We're just going to pour our liquid mixture in. Simple. So then we're just going to just put the lid on and make sure that, as a safety precaution, make sure that this thing is horizontal. If this is not horizontal, it is to say, if it's like this, mean to say it's vertical, it means that it's open. And when it's open, you're going to have your liquids flowing out, which is something that we would like to avoid in our lab for safety purposes, unless you don't want to be safe or anything. But please be safe. There's other people as well. So anyhow, make sure that it's horizontal. You pour in your liquid mixture, then just cup it in. Then you're just going to put it back here, as such. So from here, we want to extract acid. That's going to be my point. So I'll be passing on the extraction of base and neutral to Brother Abdullah after this. So let's just do a basic rundown, shall we? Let's just do a basic rundown. So going back to our basic chemistry on acids and base. So as we all know that acids react with base to form salt and water, right? That's basic chemistry, right? So when you have that, knowing that property, we know that we can utilizing this property, we can actually differentiate and extract the acid from our liquid mixtures now, because this mixture is going to have like base, acid, neutral. We only want the acid. We are only concerned with acid at this moment. So you're going to have to utilize something to make sure that the acid comes out. So how do we make sure that acid comes out? So basically, we know that acid reacts with base, right? So basically what we do is we're going to add base. So basically, adding into our adding into our funnel, we're going to add sodium hydroxide. Sodium hydroxide, we just add it in, then you just cap it, and then you're going to pull this thing out. You notice that it's going to be mixed. So to mix it, you're going to have to give it a little shake, of course. Also make sure that, again, make sure that this is horizontal as well, so that if you're shaking, it won't spill out from this side. And make sure if you're shaking, even while it's horizontal, make sure you're not shaking in the general direction of someone else. Meaning to say, if there's someone next to me, I would prefer to shake it somewhere on this direction. So, going back to the topic on hand, which is on mixing. So basically, you just give it a shake. And remember to occasionally open it. You stop for a while, then you're going to open it. Just give it a little, do it slowly, just give it a little nudge. Then you're going to hear a pop sound or hissing sound. Depends on how fast you open it. So then, this is going to relieve pressure, and because there's going to be pressure build up when you shake it. So it's best that we alleviate this pressure for safety purposes as well. So after you make sure that it's well mixed, you're going to put it back here, and then you're going to notice something. You're going to notice that there's going to be 2 layers. So layer number 1, let's just assume that it's going so as you all know that density on a comparative scale of specific gravity, water, let's just approximate it to 1 specific gravity, right? So if water is 1 specific gravity, then dCm is going to be 1.33 sgs. So you're going to notice that when there's 2 layers, the layer at the bottom will usually be the denser layer, the heavier layer, that has more mass per unit volume. And the top layer will be the less dense layer. So basically, you're going to have dCm, the dCm mixture at the bottom. So when you have the dCm mixture, you're going to have to take the mixture flask again. And then, similar to how you guys do titration, you guys have already done titration like in the past, probably in CFS, probably in matriculation. So what you're going to do is basically you're just going to open the lid slowly, open this funnel slowly, make sure that it's going to come out, make sure that the bottom layer comes out, and when the bottom layer comes out, make sure to close it in time before, to make sure that there's no mixing of the acid that we want, because we're trying to get as much acid inside of this flask as possible, because extraction, right? Want to extract, not mix. So anyhow, what was I talking about? Yes, basically you do it like how you do your titration, make sure that you're going to get everything out, and then this is going to be your mixture. This is going to be this mixture is going to contain neutral substance, basic substance, and your DCM in the start. So basically, what you left here is going to be your acid. So when you have your acid, you can just just open the funnel and just empty it out. Just empty it out as such. When you empty it out, but you also have to take into consideration for this one, for the mixture flask, that are you sure that it's going to be 100% extracted of your acid? Acid is 100% extracted from this mixture. Ideally, you want to say yes, but come on, we live in the real world. Of course, it's going to be a no. So basically, you're just going to report it again, get it inside, and then you repeat the same steps again. You add your base, then you just filter both, and then you're done. So basically, you just do it as many times as you can. But as we did in class, we basically just did it like 2 times. But you all get the idea, right? You all get the idea. So I'll be passing the floor to Brother Abdullah. He'll be explaining on how to extract basic and neutral compounds, and he'll also be explaining the industrial significance of why liquid extraction is essential. Wabillahi taufiq wa hidayah. Assalamualaikum. I'll pass the floor to you now.
Bismillahirrahmanirrahim. Thank you kepada Brother Afif Imran for the. So now I will continue the experiment from separation of base. So in this mixture flask, they still have neutral and base. So I'm gonna just follow the same step like separation of acid, but for separation of base, first we put the mixture flask in the separatory funnel, and then for separation of base, we add 10 ml of 5% hydrochloric acid, and then after we add the hydrochloric acid, like usual, we will shake the separatory funnel. Make sure it's not direct to a person. Shake, and then for a while we open, close it back, and shake it back. And then after we satisfy, we put it back in the laptop stand. And then in the separatory funnel, we can see there are two layers. There are at the top will be base, and the bottom will be neutral, a mixture of neutral and base. Because the mixture of neutral and base is much denser than the base at the top. So we extract the first layer, the base mixture of neutral and base, to the mixture flask. We open the lid first, and then we extract. And then after all the mixture of neutral and base is already out from the separator funnel, and then what we have in the separator funnel is only base. So we put what left inside this into the base flask, and then we can repeat the step again to get a little base that's still in the mixture flask. So after we finish that, we can get the acid flask, the base acid flask that contain pure acid, base flask that contain pure base, and then mixture flask. We can put the what left in the mixture flask into the neutral flask, and then we can get 3 pure acid, pure base, and pure neutral. And by that, that's the end of the experiment. So after that, I want to move on to the how can liquid extraction principle be applied to the industry. So for this, we must know first what is the principle of the liquid extraction. So for liquid extraction, the most basic principle is how it works based on differential solubilities of a substance into immiscible liquids, which is the two immiscible liquid is one is organic phase and the second one is in solvent phase. So for this, I'm gonna use the example from petrochemical industry, where we will separate use the principle of liquid extraction to separate aromatic hydrocarbon compound from the non-aromatic hydrocarbon compounds. So in this experiment, the industry will use the equipment that we call RDC, or rotating disc contactor. The rotating disc contactor is a vertical cylindrical tall column that has a rotating disc inside it. So using the equipment, we will feed with a mixture of hydrocarbon that have aromatic compound and non-aromatic compound, and then we will add solvent, and then the machine will rotating with spin continuously, and then the mixture of the solution in the machine will be mixed and will react with each other. And then after a while, we can extract the aromatic hydrocarbon compound such as benzene, toluene, and xylene from the mixture. and then we can use that for another process. Why liquid extraction principle is convenient, is what we call industry must use it, because by using the principle of liquid extraction, the liquid extraction is not what we call temperature dependent. It can be operated at moderate temperature, and it also can be at large scalability. It can produce at a large product, and then the solvent can be recycled back. I think by that's the end from our presentation. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. We are from Group 2. My name is Muhammad Hazami bin Muhammad Nasir.
My name is Shamim Amar bin Fahmi.
My name is Nafis Ukasha bin Nasaruddin.
And today we will be presenting about liquid extraction. Okay, so firstly, I'm Hazami and I'll be responsible for the part of introduction, problem statement and precautions that we took during the experiment. So first, we'll go to the introduction. So sometimes, upon the extraction of a natural tissue, a complex mixture is formed, in which case, additional separation methods must be used, and these extra steps were performed in order to remove impurities to obtain the pure substance that we require. And one such method of separation is the separation of the constituents of the mixture into three classes, which are basic, acidic, and neutral. Which brings us to our problem statement. Naturally, a complex mixture will contain other compounds, and some of those compounds we may not need, so we call them impurities. So, how do we identify and separate these impurities from the mixture in order for us to obtain its pure substance, pure form? So, the procedure is possible because according to our hypothesis based on the solubility difference principle, by reacting based on our hypothesis, which was based on the principle of solubility differences, an organic compound containing an acidic, a basic and a neutral component can be successfully separated by reacting the acidic component with an aqueous base and reacting the base component with an aqueous acid. This will convert them into water-soluble salts, allowing for us to isolate the neutral component because the neutral component will remain dissolved in the water-immiscible organic solvent. So now, moving on to the last part, which is the precautions. So for general safety and personal protection, each of us wore these long sleeve lab coats like this and chemical resistant gloves, which are like this, the latex gloves. And in the experiment, one of the substances that we use is known as diethyl ether, which is known to be extremely flammable and its vapor are heavier than air molecules. So, if the substance is handled incorrectly, the vapor of the diethyl ether can travel along the tabletop and be ignited by nearby heat source. So, as a matter of precaution, within the area of the experiment, any potential heat source must be removed. Other than that, since a strong base and a strong acid is used in the experiment, we were extra careful to pour the reagents to avoid them from splashing and making contact with our skin or eyes. And lastly, all work involving volatile organic components and concentrated reagents were performed in a well-ventilated fume hood, which is located at the back of the laboratory. So now that will be all from me. I'll pass the presentation to Brother Amer.
So now I'll be telling the story of how we ran our experiment. I'll be separating them into three stages. Stage number 1, preparing the mixture. But first, we need to have ready 3 labeled beakers, each labeled acid, base, and neutral. So for the starting point, we need to add 0.2 grams of acid, base, and neutral using a spatula And obviously from the substance preparation section, we had set measurements into one conical flask. So these are in a solid form. But for this experiment, we need them to be in liquid form. So how do we dissolve these substances into liquid form? Brother Imran, could you tell me what substance could you add into these three substances so them could be dissolved into liquid? Correct. For those who are watching through the screen, the answer he just told me is DCM, which is also known as dichloromethane. Okay, so now we add dichloromethane into these three substances, but they are not mixed, so we need to swirl them until it is visibly in the naked eye, it is dissolved. So we swirl them until it is dissolved, and it is ready to be used for the experiment. So we pour them into this separation funnel, and remember, use a, what is this called? Filter funnel, correct, thank you. Filter funnel, and we pour them into the separation funnel. So now, moving on to stage number 2. What is stage number 2? Stage number 2 is the separation of acid. Separation of acid. So how do we separate acid from a mixture of neutral, base, and acid? So we need to add base, so it reacts with acid. What base? Sodium hydroxide. So we use a dropper and a measuring cylinder. We collect 5 milliliters of sodium hydroxide and drop them into this separation funnel. After we've dropped them, just like before, it is still not mixed. So how do we mix the substances in this separation funnel? So we take the separation funnel out, we turn it upside down, and of course, I forgot to mention, when we pour the substance into the separation funnel, this stopcock needs to be closed. Vertical means closed, and horizontal means closed, and vertical means open. So for the mixing section, we need to make sure that this red thingy is closed. So we take it out, make sure it's closed, and then we shake it vigorously. We shake it vigorously, and you can see that after some time, there will be bubbles being formed inside this separation funnel. So we need to remove these bubbles. How? We just simply open the stopcock until you could hear a pop sound or something similar. And you could do this many times, couple of times, repeat it and repeat. But at the end of the day, all we want is just to mix it. So until you are satisfied, you could now put it back onto the retort stand and prepare for the extraction. Bear with me for a second. Okay. Okay. Wait. Okay. Now, acid extraction. We take the acid conical flask labeled conical flask, and we put it under here. Wait. I forgot to mention. My bad. After we mix, there will be 2 layers of liquid. And these 2 layers, the bottom layer would be the more dense, which is the mixture, and the top layer would be the less dense, which is the acid, which is what we want. So, the bottom is the mixture, so we take the mixture conical flask. We take the mixture conical flask, we pour it out. And again, some of you may forget, when you want to pour the mixture out from this separation funnel, you need to open the lid. So it actually pours out. If not, it does not pour out. So we pour it out until at meniscus level, you can see that the bottom layer is already fully poured out. And after it's poured out, we stop to make sure all is left is the acid. So now we have only the acid. Now we take the acid conical flask, and then we pour out all the leftovers. We pour out all the leftovers. What happens? This is pure acid. This is what we want. And we have 2 conical flasks with pure acid and a mixture. But this mixture, it has neutral, base, and still a little bit of acid. So basically the separation of acid is doing this method, repeat it over and over and over again until you could say that acid is fully separated from the mixture, or at least you are satisfied with your result. So that is for stage number 2, the separation of acid. Now moving to the last stage, which is stage number 3, the separation of base. How do we separate base from the mixture? You add acid. What acid? In this case, we add hydrochloric acid. Again, using a dropper and a measuring cylinder, but a different one. We add 5 milliliters of hydrochloric acid into the leftover mixture. So, now we have, again, just like the acid separation, it is still not mixed. So to mix them, we take it out, we turn it upside down, we make sure this is closed, we shake it vigorously. And if you see bubbles being formed, you open to release pressure and you hear a pop sound. And then we close it back, and then if you're done, if you're satisfied with the shaking, you could put it back in and get ready for the extraction. So just like the acid again, to separate this, we have 2 layers. In this case, the top layer is the base and the bottom layer is the neutral. The top layer being pure base and the bottom layer being neutral with a bit of base. So again, using the mixture conical flask, we extract first the mixture out, making sure all the bottom layer is poured out, and again take off the cap, make sure all the bottom layer is poured out, and continue on with all the leftovers with base. And then we have 3 conical flasks with acid, pure base, and pure, well, not pure yet, neutral. But in this case, neutral still have some leftover base. So just like the separation of acid, this could also be being done repeatedly until you are satisfied with the extraction. So now, at the end of the experiment, all we have is 3 separate conical flasks, one being pure base, one being pure acid, and one being neutral. And that is all for the procedure of liquid extraction. I'll pass the discussion on to Brother Ukasha.
Alright, Bismillahirrahmanirrahim. So I will continue what has been discussed by Brother Hazami and Brother Amer. Actually, this is an experiment of liquid extraction, and the main purpose of this experiment is to demonstrate the acid and base reaction that can use to separate different compounds. So liquid extraction is not only used in our laboratory, it also used in our real life industry, such as one company named CR3. So what is CR3? Actually, CR3 is the company that stands of coffee refining company in Germany. So this company used the process of decaffeination. So decaffeination is the process to separate the caffeine from the coffee, from the coffee bean. So this is crucial because this process uses the liquid CO2 as the selective solvent to separate the caffeine. So I will explain the process of decaffeination by CR2 in Germany. So for the first one, same as the other process, the decaffeination process begins with the preparation of the coffee bean. So preparation of coffee bean starts at the humidifying tank. So at this tank, actually the coffee beans is hydrated by steam and water. So when the coffee beans absorb the water, so the cell walls of the coffee bean will swell, and the internal pores of the coffee bean will open up to the, which is to to upgrade the surface area. This is for the preparation of the extraction step for the next step. So for the next step is, this is where the extraction process happens. So the extraction process happens when there is a 6 tanks connect to each other. So for the first point, CO2 liquid will be pumped to the tank to pass through to the coffee bean, chain by chain until the last tank. So in the tank, actually the CO2 liquid is a very selective solvent. So it will dissolve the caffeine but not other flavor and aroma compounds such as acid and oil. So after that, at point 3, the CO2 liquid that full of caffeine is pumped out from the tank to the new facility, which is full of water. So at this new tank, the CO2 liquid will go to the new state, which is gaseous state. So at this state, CO2 is no longer able to carry the caffeine. So it releases the caffeine to the water. So at the next step, the CO2 gas is go through this and go to the new column. So at this column, CO2 gases is condensed back to the liquid and go through the cycle back. And this cycle is continue until the caffeine level desired reach. So after the extraction, we need the process of drying the coffee bean. So this is the tank that used to dry the coffee bean. So after the extraction process, actually the moisture level of the coffee bean is around 50% to 60%. So this process helps to reduce the moisture level to 10 to 12%. So after this process, the coffee bean is ready to serve and packaging. And that's all from us. Thank you.
Assalamu alaikum wa rahmatullahi wa barakatuhu. My name is Zubayda Niaz Abdurrahman.
My name is Fatima Jawadafa.
We are from Group 3 and we will be presenting on distillation. So distillation is one of the most fundamental separation techniques which we use in not only labs but also in most industries. So distillation works on a really simple phenomena, that is different liquids boil at different temperatures. So in chemistry we deal with a lot of mixtures, but how do we separate them? Or more importantly, how do we separate them without changing their chemical composition? So that's where we use distillation. So let's, for example, let's take a mixture. Now, when we heat up this mixture, the liquid with a lower boiling point will vaporize first, and then it will get cooled down and condensed back into a liquid, which will help us to separate all the different components in that mixture. So here we have a small distillation setup. So our process begins from this round bottom flask. This round bottom flask is supposed to be bigger so that it will fit into the heating mantle. So in this mixture, we are, inside this round bottom flask, we are using a mixture between dichloromethane and a base. But we also add anhydrous sodium sulfate to remove excess water, and also boiling chips to prevent bumping. So we start by switching on this heating mantle, which will then heat up this mixture. So once this mixture starts heating up, we can check the temperature on this thermometer. So now this thermometer actually has two purposes. One is to measure the temperature of the mixture, or not the mixture, but the component which is getting distilled. And there is also another, this thermometer also has another purpose, which is to act as a stopper, so that the liquid which is getting vaporized will not go into the air. So when DCM is getting vaporized, At the same time, there is cooled water running through the outer jacket of the condenser. So that this cold water will help the vapor to cool down, so that it will turn back into a liquid and it will go like this and get collected. DCM will get collected in this receiving flask. So this distillation setup is really small scale and we only use it for labs. But if you're talking about industries, so unlike here where we use glassware, in industries like crude oil, for example, they use tall fractional distillation columns where they separate one mixture into many components, unlike here where we're just separating 2 or 3 components. So crude oil will get separated into kerosene, petroleum, gasoline, and many more compounds, which Fatima will go more into later on. So the difference lies in, so like even though the principle is the same for labs and industries, the difference lies in the scaling of the process, the equipments that we use, and also just the process of our separation. So that's it for me, and I will pass it on to Fatima, who will talk about safety precautions and industrial applications. Thank you.
Assalamu alaikum. I will be speaking on the safety precautions and the industrial applications where distillation is used. Now, one of the safety precautions we have to adhere to during this process is the use of anti-bumping granules to prevent our liquid from boiling too vigorously, which can cause our round bottom flask to explode and can cause serious injuries. And another one is the addition of anhydrous sodium sulfate, which acts as a drying agent and removes traces of excess water in our organic solvent, which prevents the water from boiling at the same time as our desired product. Lastly, make sure your keg clips are secured properly to make sure your distillation setup does not fall apart during your experiment. Now, onto the industrial uses of distillation. One of the industries where distillation is used is in petroleum refinery. Petroleum refinery is a process that converts crude oil into useful products like petrochemicals, lubricants, and fuels. And crude oil is a mixture of hydrocarbons with various boiling points and molecular structures. This crude oil is separated in a process known as fractional distillation, where the crude oil is heated at a temperature of about 600 degrees Celsius, which vaporizes most of the crude oil, turning it into a liquid vapor mixture. This liquid vapor mixture is then pumped into the bottom of our fractionating column, which has a temperature gradient that is hot at the bottom and cold at the top. Hot at the bottom and cold at the top. Okay, it is hot at the bottom and cold at the top. As the vapor rises and cools, the hydrocarbons will be collected at different intervals. The hydrocarbons with higher boiling points will condense at the bottom of our fractionating column and will be collected at the lower levels, while our hydrocarbons with lower boiling points will rise to the top of the fractionating column and will be collected at the top of our fractionating column. These condensed liquids will be collected into plates and trays, and then will go through extra refinery processes before they are released towards the public for consumption. That is all I have for you today.
So, Assalamu alaikum warahmatullahi wabarakatuh, and very good evening to all of you. So, my name is Aish Mahira. My groupmate is
Inas Anis.
And today we are going to discuss about separation technique, which is distillation. So before we go beyond, I will explain a little bit about this about separation of liquid. So separation of liquid is either you use liquid extraction or distillation process. So what is the difference between these two processes? So for the liquid-liquid extraction, we use immiscible liquid, while for the distillation process, we use miscible liquid. Alright. So there are 7 main apparatus that we need. First, the distillation process is widely used in industry and lab purpose. Because why? Because it is easy to understand and practicable. So in front of me there are 7 main apparatus of distillation process. For the first one is heating method, and then we have distilling flask, condenser, and then receiving flask, thermometer, and distilling flask. That's all. So what is the idea behind this process? So the idea is behind this process is we need to have a miscible liquid, and then you're heating it up. So the liquid that have low boiling point will vaporize first, and then the remaining will stay at the distilling flask. So the problem of this experiment is we need to separate the mixture of dichloromethane and also the base. So I will pass this stage to the next presenter, Sister Ines.
Alright, so right now, first I want to apologize in advance if I speak like slowly or if I cough in the middle. I'm not feeling well. But now I would like to explain about the precautions we took before conducting this experiment. And as you can see, if you've noticed, my lab coat is not buttoned up. So that's like one precaution you need to have, which is to properly button up your lab coat or you'll be kicked out, okay? Okay, so besides our lab coat, we also made sure to wear gloves in case we get any splashes from the chemicals and whatnot. And what other things we have to be cautious of is because we have a heating mantle, we need to make sure that there are no flammable materials nearby. And while conducting our experiment, we should always keep our workstation clean and proper. Okay, so moving on. I will explain the procedure of distillation, a simple distillation we can do in a lab. So before we boil or heat up our mixture, the first thing is we want to prepare the mixture, which is our mixture of DCM, dichloromethane, as well as base. We will add anhydrous sodium sulfate. And what anhydrous sodium sulfate does is it will absorb any excess water so that we don't have any water left here. Yeah. And then we also added these anti-bumping pellets or granules so that our mixture doesn't splash uncontrollably. So that like when it gets superheated, we don't freak out, everybody stays calm. Next, once we've already prepared our mixture, we will heat it up, and as my friend earlier mentioned, the principle behind distillation is the different boiling points. So dichloromethane has a boiling point of 40 degrees Celsius, and we have our thermometer here to make sure that our mixture is at 40 degrees Celsius. So that because, okay, the thing is, if we go above 40 degrees Celsius, there's also our base in here. And if our base also vaporizes, and then it goes through the condenser, then there will be no point in doing this experiment, okay? So we have our thermometer, and we will keep track of our temperature while it is heating. And our DCM will vaporize, and once it vaporizes, it will go through this condenser. And something to note of is that our condenser, it has like an outer jacket to say, And that outer jacket, what goes through that outer jacket is cold water, running cold water from here, lower to higher, because we want to avoid air pockets. And this is so that our vapor can cool efficiently and condense. And then the vapor will go through here, and it will end up in our distillation flask. So in the end, we will have pure dichloromethane in our distillation, in our collecting flask. I'm sorry guys, I lost the plot for a moment. And over here, we will have our base. Yes, that's the principle behind it. And something to note of is we need to make sure that everything is secure so that we can conduct this experiment smoothly. And I think that's it for my part. I will pass the floor to Alia, who will explain about the real-life applications of distillation.
I am presenter number 3, and I will discuss about how the principle distillation is applied in the industry. So as we all know, the common example is petroleum refining. So the process of petroleum refining is where the crude oil first will undergo the simple distillation. Why it undergo simple distillation? Because it's important to stabilize it before it's heated and enter the fractional distillation tower. And after the crude oil enter the fractional distillation tower, the mixture will be separated into the stage based on difference of boiling point. So for the top of the fractional distillation, where has the lower boiling point, is a butane, and then followed by petrol, kerosene, diesel, and fuel oil. And the product will be used in the petroleum industry. Other industry that use principal distillation, perfume and essential oil industry, they use two types of distillation, steam distillation and simple distillation. Steam distillation works in we boil the water first, and the steam from the water boil will undergo through the bots. The bots have a plant that you want to extract. The smell oil will, and the steam will carry the steam from the hot water will carry the smell oil from the plant and undergo the condenser, and then will become to liquid and obtain oil and water. Then all this compound will be separate and purified using the simple distillation, and you will obtain a pure water and pure oil. And other application industry that use this distillation is chemical and pharmaceutical industry, where it is commonly used to separate and purify the pure components such as acetone, methane, and diethyl ether. This pure component then will be reused in the industry. It is important because it helps to reduce the production cost. Thus, this minimize the chemical waste. And other example that use distillation principle, for example, alcohol industry. alcohol industry separate the ethanol and water using distillation, and then distill water to obtain a pure water, and then to extract flavor for food industry. And overall, distillation principle has been widely used in many industries, which is important for growth of a new technology and discover a new technology by using the principle distillation. That's all from me, and thank you.
Assalamualaikum and a very good afternoon. We are from Group 5. We are doing the presentation on the thin layer chromatography experiment. My name is Irdina.
My name is Aish Syahira. And my name is Nurul Fatihah.
Thin layer chromatography is known as TLC, is a solid liquid separation, partitioning techniques that used to determine the purity and also as well as the preliminary compounds. It is used it is based on the polarity of solvents. The compounds will be separated by two different phases. The first one is the stationary, which we use the thin layer plate, as well as the mobile phase, which is the solvent system. So when we talk about solvents, the solvents that we are using is the two different solvent mixtures. The first one is the mixture of hexane and ethanol, and the other one is DCM, which is dichloromethane and also hexane. We are going to use the mixture solvents and spot it on the TLC plate, and then we will put it in the developing chamber and allowing the solvent mixtures to migrate up to the top of the plate by the capillary attraction. And then because of we are using to determine the best optimum solvent. So now, in order to choose the best solvent, it is always based on their polarity. So we are going to. So the polarity is chosen. So what are the expectations from this experiment? So we are assuming, we are expecting the non-polar compound will travel further away up to the top of the plate compared to the polar compound. By saying this, we are expecting the RF values, which is the retention factor for the polar compounds. We have lower values compared to the non-polar compounds. So the RF values is the retention factor, which is the ratio of how much travel distance by the compound to the how much travel distance by the solvent. So to get the accurate and also the accurate separation efficiency, we have to choose the optimum solvent. So to choose the optimum solvent, it is a challenge for us because different solvent has different polarity, and the polarity is affecting their interaction between the plate and also the molecular compound. And then these are the we can say that polarity of the solvents are the main role, the critical role in this thin layer chromatography experiment. So these are the apparatus that we are using. We are using three different compounds, which is the acidic, which is we are using the benzoic acid, and then we are using neutral compound, which is the camphor, and as well as the basic, which is from the p-chloroaniline. And then we have the flask to put in the liquid substance, the developing chambers with two different solvent mixtures, and the TLC plates, which is the stationary phase. And then we have the capillary tube to spot on the compound solution on the plate. So this is much better to use capillary tube because it can prevent from the spot to relapse with the other solution next to it. And then we also have measuring cylinders to measure your solvent. We are using a forceps because the plate is extremely sensitive. So to avoid contamination, we are using forceps. And then this is the micropipette to, I'm sorry, we're not using this. And since we are dealing with the colorless solution, we are using the UV lamp to help to detect the spots on the plate. And now I will pass to Aisha to proceed with the procedure.
So let's continue with the procedure of the experiment. First, we need to prepare the TLC plate. Assume this is our TLC plate. Using pencil, draw a horizontal line about 1 centimeter from the bottom of the plate. Along the baseline, label the spot for each sample solution, which is A for acid, B for base, and N for neutral. After that, draw a line about 1 centimeter from the top of the plate for solvent front. So this is for developing solvent, which are hexane ethanol, labeled as HE, and dichloromethane hexane, labeled as DH. So next we proceed to produce sample solution using 3 separate beakers. So we label each of the beaker as acid, A, B for base, and N for neutral. Then we use measuring cylinder and filter funnel and put 5 ml of dichloromethane into each of the beaker to dissolve each compound. And put them aside for spotting later. Next, we provide 2 developing solvents by placing 5 ml of hexane ethanol with ratio 9 to 1 into the first flask, and placing 5 ml of dichloromethane hexane with ratio 9 to 1 into the second flask. Next, using measuring cylinder and filter funnel, we put 5 ml of each developing solvents into the developing chamber, and make sure to close the lid to prevent the solvent from being evaporated. Next, we put them aside and we move on back to our TLC plate. Using forceps, we put our TLC plate into the developing chamber and make sure it's vertical and close the lid, and let it rise within 1 centimeter from the top of the plate. Once it's done, we remove the TLC plate from the developing chamber, and now we can measure the spot patterns on the TLC plate. But we cannot directly use our naked eye, so we need to use UV light to visual the spot and outline each of the spot. Finally, we can measure the retardation factor, which is B over A. For B, we measure the distance between the baseline to the center of the spot, and for A, we measure the distance between the solvent front to the baseline. And next is the health and safety precautions. First, we need to wear our lab coat, our glove, and closed shoes to prevent us from harmful and chemical toxics. For example, dichloromethane. Dichloromethane is volatile and toxic. It can cause burns and skin irritation. So by wearing gloves, we can protect from dichloromethane absorbed through our skin. Next is by handle the UV lamp safely. When in this experiment, we use UV lamp to visualize the colorless compound on the TSC plate. When we visualizing the spot under the lamp, we cannot directly look into the UV lamp because intense UV radiation can cause eye irritations and skin redness. So we need to use transparent UV protective screen that made of polycarbonate material. And lastly, when we prepare the TSC plate, we use the pencil rather than pen. This is because from the pen contains dyes and organic solvent that can dissolve or spread when the TSC plate is placed in the developing solvent. So it may be interfere with movements for spot sample or create extra spot on the TSC plate. So it can result leading to an inaccurate result. So lastly is that's all from me, and I will pass to the next presenter.
Okay, hi everyone. So I will continue the experiment, the presentation with the result, the discussion of the result. Okay, so this is our result. As you can see, this is mixture of hexane and ethanol, and this is the DCM, dichloromethane, and hexane. Okay, let's put aside first. So we want to discuss about the theory, the hypothesis theory. The hypothesis theory said that the RF values increase with the polarity of the solvent because it can make an interaction. The solvent polarity will make the interaction with the silica gel. As we know that silica gel is polar substance, so it will make the interaction and the compound will move further up on the TLC plate. Okay, so as we know that our silica gel is polar substance, our A and B, which is acid base, is polar compound, and the neutral is non-polar compound. And now we need to identify, is our mixture is polar substance or non-polar substance. So, okay, let's take a look first for hexane and ethanol mixture. Okay, for hexane is non-polar compound. This is because it is hydrocarbon and have intermolecular forces that weight in intermolecular forces. So ethanol have is a OH group, which is it can form hydrogen bond. So it's polar compound. So when it mix both of it may, if we mix in same ratio, it will give polar solvent. So that is why we mix with 9:1 ratio, which is hexane is 9 and ethanol is 1. So when we mix it like that, it will produce as non-polar mixture. So as we can see, our result is when we immerse the TLC plate in the solvent, the acid and base will move slower than this result, because the compound that non-polar mixture, the mixture with non-polar will not interact with the silica gel. So the silica gel will interact with the compound. When the interaction between the compound and the silica gel, that is why it moves a bit slower. Okay, then the neutral is move more faster than other compound, because there's no, when the mixture is non-polar, it will interact with the neutral, because neutral is non-polar, so it will move faster up like that on the TLC plate. That is why no neutral here. Okay, for DCM and hexane, DCM is moderately polar, but the ratio to the hexane is 9:1. So the mixture automatically become polar solvent. So when we immerse the TLC plate in the polar solvent, the polarity of solvent will make an interaction with the TLC plate, as the TLC plate is polar. So when it interact with the TLC plate, so compound will move up further on the TLC plate. So the hypothesis is accepted. Okay, so next I would talk about the industrial applied TLC experiment for our industrial. So there are three largest that we use for TLC experiment, which is in clinical, pharmaceutical, and food testing. Because as we know that TLC is cheap, fast, and simple, so we don't need to make it automated. We just need to do it manually. Okay, so in clinical, basically they use for presence of drugs of abuse, and in pharmaceutical, it is widely used for production and quality of the production. Let's say in the tablet of medicine, they will make sure that there is no impurities in the tablet. It only contains of active ingredients. And for food industrial, maybe they will make sure that the flavor food don't have any impurities that harm for human use. I think that is all from our groups. Thank you.
Assalamualaikum warahmatullah. We are group 6 from section 2, and today we will present you about thin layer chromatography. My name is Sofia.
My name is Arisa. My name is Ayuni.
Okay, Bismillahirrahmanirrahim. For introduction, thin layer chromatography is one of chromatography technique to separate compound of mixture based on their polarity and their attraction with the between compound and two phases. So in this experiment, we have two phases. Okay. So first phases is stationary phases, and the second one is mobile phases. So the first stationary phases in experiment is silica gel TLC plate, which is a polar plate, and then the mobile phase is our developing solvent, which will move further up to the plate. So So the principle behind this experiment is that each compound has their own polarity. So that means the more polar the compound, the component, the more interaction between the compound with the stationary phase. So when it has interaction, the more slower it will migrate on the plate. So if opposite one, the less polar, the interaction is weak between compound and the stationary phase, so it will migrate fastest and the distance is more higher, increase. So, and in this experiment, we will have two types of solvent, developing solvent. First one is we will use dichloromethane and hexane, and then the second one we will use hexane and ethanol. So, after this experiment is done, we will see on the TLC plate, for the both of TLC plate, we will see there is difference in distance between, there is different in distance and RF value between two TLC plate, because even the solvent has their own polarity. So, the solvent itself also influence the movement of our compound. Okay, so that's it. In industry and laboratories, there is some difficulty in separate some component that has similar chemical properties, like they have the same polarity maybe, and so this chromatography, thin layer chromatography, is the easiest and inexpensive way for us to separate and identify the component, whether it is pure or impure. So that is for introduction and problem statement. Now I will tell you the apparatus and equipment we will use in this experiment. So firstly, we will use TLC plate coated by silica gel, and then we will use 3 beaker, which will contain our 3 compound, which is acid, base, and neutral. And then we will use developing chamber, where we will put our TLC plate and developing solvent. And this too is for mixture of our developing solvent. And lastly, our measuring cylinder to measure. And then UV lamp to visualize the movement of our component on TLC plate. So that's it. I will pass to the next person.
Okay, thank you to Sister Sophia. So next, I will be presenting to you about the procedure, result, and the discussion. Okay, firstly, for the procedure, we will start with preparing our 3 compounds, which is acid, base, and neutral. So firstly, we will put tiny amounts of our compound in each of this beaker. Then we will dissolve this compound with 5 ml of dichloromethane. So, then we've done with this compound. So next, we will prepare our TLC plate. These 2 TLC plate will be used for 2 different solvents, which is the DCM and hexane, and ethanol and hexane. So first, we need to use a pencil and a ruler to make the baseline and the front line like this. This is 1 cm from the bottom and 1 cm from the top. Then you will need to label for each of the TLC plates for its solvent. Like this is for hexane and ethanol, and this is for DCM and hexane. Okay, then we will prepare our developing solvent, which is the first one. Oh, don't forget to label your flask. So this is for the DCM and hexane. So we will put DCM and hexane in ratio of 9:1, and we will put hexane and ethanol also in a ratio of 9:1. So after we have prepared our developing solvent, we need to put our developing solvent into our developing chamber. So this is 2 developing chamber for our different solvent. So we need to use the cylinder, measuring cylinder, and the filter funnel. Then we will put the solvent here and measure it 5 ml. And then this will be put in each of the developing chamber. So we will do the same for the other chamber. So don't forget to close the chamber lid so that the solution will not evaporate to the air. After that, we will use a capillary tube to take our compound from this beaker to our TLC plates. So, don't forget to label for your compound, which is acid, base, and neutral. And then we will spot the compound each at the baseline. This. And then we will use a forceps. Then we will put our TLC plates inside of our developing chamber. We need to put it vertically. Make sure it is straight like this. Then you need to let the solvents inside to move up until the solvent front. This up until here. Then after that, you need to take out the TLC plate, and then you need to let it dry for a while. And that's it for our procedure. So next is the result of our experiment. Okay, for the first solvent that we use, which is the DCM and hexane. So this is the result that we can see, which we can observe that the acid and the base move further upwards, comparing to this hexane and ethanol. It moves just slightly from the base. Why does this move further? It is because the DCM and hexane solution is moderately polar. So when it is moderate polar, our silica gel is also polar. So the solvent will react with our silica gel. So which means that our acid and base will move further from the silica gel. Meanwhile, for the hexane and ethanol, this is non-polar solutions, non-polar solvents. So when it is non-polar, our polar acid and base will react with the silica gel. So there is an interaction between the compounds and the silica gel. So it will not move further. So as you can see here, as you can see, about our neutral, you cannot see the neutral, right? Because our neutral is non-polar. So when it is non-polar, it will move the furthest away from this. So it will just disappear like that. Okay, I forgot to mention that after we have obtained the TLC plate, we need to use the UV light for us to visualize the spot on the TLC plates. So, when you are using the UV light, you need to at least have a cover like this. You need to put the cover like this so that the UV light does not get into your naked eyes. So that's all from me. I will pass to the next presenter.
Okay, so I will talk about safety steps that should be obeyed to do experiments. First, in this TLC experiment, we use chemical solvents such as hexane, dichloromethane, and ethanol. These chemicals is toxic and flammable. Therefore, we should do in in a well ventilated area and avoid open flames. Next, we should always wear proper lab attire, which is our lab coats, gloves, and closed shoes to prevent our skin from chemical splashes. And then, when using the UV light, do not directly look into the light because it can damage our eyes. So we must use UV shield or any protective glasses to protect ourselves from UV exposure. And then for precautions to ensure that this experiment conducted to get good and reliable results. First, make sure to label of all samples correctly to avoid any confusion later in the experiment. And second, make sure the TLC plate is clean and dry, because if it's dirty or has any fingerprints on it, it will make the solvent not move evenly. And then during the developing process, make sure the solvent level is below the sample is below the sample spots, because if it's too high, the sample will dissolve directly into the solvent instead of separating properly. And then when marking the baseline or solvent front, use a pencil, not a pen, because the ink from the pen can dissolve in the solvent. And then okay, that's all for precaution steps for this experiment. And next, I will tell you about the 3 main examples for this TLC that use TLC in real life. Okay, first, pharmaceutical industry. In medicine industry, TLC is used to separate. TLC is used to. TLC is used to check the purity of the samples and ensure that there are no. To check if there is any impurities formed in the products. For example, a company make a tablet. They use TLC to check to check the impurities formed in the tablets and identify each compound of the tablets. And next industrial application is forensics industry. In forensics, they use TLC to identify the unknown substances like drugs or ink or dyes that found in crime scenes. So, for example, for example, the ink from the pen and the ink on the notes, they try to identify whether if they are matched, then they found the suspect, like the evidence. Okay, so to conclude, to conduct this experiment properly, we must
obey the safety and precaution steps, and also follow each steps very carefully, and to obtain the clear results. And also, TLC is widely used in industry to separate and identify of organic compounds. That's all from our group. Thank you.